knows what movies you'll like, or how Amazon can pull up every single blue shirt in your size in like a split second. Well, there's a secret language working behind the scenes of pretty much everything we do online. Today, we're going to pull back that curtain and learn how to speak it. We're talking about SQL. Let's dive in. So here's the game plan. We'll start with what SQL even is. Then we'll get our hands dirty building a place for our data, asking it some questions, fine-tuning our search, and, of course, keeping things neat. By the end, you're going to have a solid toolkit for talking to data. Here's the deal. The entire digital world runs on information. We're talking mountains and mountains of it. The real trick isn't just having all that data, it's being able to find the exact little piece you need right when you need it. I want you to imagine for a second that your computer had no folders, just one giant chaotic pile of every file you've ever saved. Finding a single document would be an absolute nightmare, wouldn't it? Well, businesses face that exact problem, but on a gigantic scale. Their solution has to be lightning fast and perfectly precise. And that solution is SQL. It stands for Structured Query Language. The best way to think about it is like a universal grammar for talking to a perfectly organized digital filing cabinet. With SQL, you can tell that cabinet exactly what to store, where to put it, and most importantly, what to bring back for you. So before we can start asking for information, we have to build the cabinet itself. We've got to create a structured home where all our data can live. And here's how we do it. This command, create table, is basically us saying, hey system, I need a new drawer and I'm going to call it project. Then the stuff in the parentheses, that's us setting up the dividers inside that drawer. We're making a spot for PID, which is an int, an integer, just a whole number. And then we have project_name and technology, which are varchar. That's just a fancy way of saying their text fields. And voila, here's what we get. After running that one little command, we have a perfectly structured but totally empty container. We've built the drawer, we've put in the dividers, and now it's just waiting for us to start filing away our data. So what's the next logical step? We start filing. In the world of SQL, we do this with the insert command. This is how we take our raw info and put it right into the structure we just built. And just like that, our table has data. See? Each row is like a new file folder put neatly into its proper spot. We've got project ID 1, which is OLB, and uses Java, and project ID 2, version, using SQL. Our digital cabinet is starting to fill up and actually become useful. Okay, the cabinet's built, the files are in, now for the fun part, asking questions and getting answers. And this is where SQL's most famous and powerful command, select, enters the picture. You can see just how flexible select is right here. On the left, we've got select star. That little asterisk just means everything. It's like telling the cabinet, just dump the entire drawer out on my desk. You get everything, but it's a mess. But look at the right. By being specific, select ID, name, age, gender, you're only getting the exact, neatly organized files you actually asked for. Much better. Okay, that's cool. But what if we don't want all the employees? What if we need a very specific group? Let's say, how do we find just the people who work in the IT department? Simple. We just add a condition. This where clause is our secret weapon. It's a filter. It tells the database, okay, go look at all the employee records, but only show me the ones where the department is IT. It is an incredibly powerful way to zero in on exactly what you're looking for. But we can do even better. We can get even more granular. SQL gives us tools to not just filter the data, but to actually shape the final result into exactly what we need. Let me show you. Two really great tools for this are Top and DISTICT. Imagine your query finds thousands of results, but you really only need to see the first few. Well, Top lets you limit that output. Super handy. And DISTICT is great for cleaning things up by getting rid of any duplicate rows in your results. Here's a perfect example. Let's say your list has 10,000 employees, but you just want a quick peek. You can just add top 3. The database literally stops searching after it finds the first 3. It's fast, it's efficient, and it keeps your results from getting overwhelming. A good filing cabinet isn't just about adding new files. You also have to clear out the old, irrelevant ones to keep things from getting cluttered. Data is exactly the same. Keeping your database clean is crucial. And for that, we have the delete command. So take a look at our employee table here. You can see we have a record for an employee with an ID of 7. Well, let's say this employee leaves the company. We need to get their record out of there to keep our data accurate. And this is the command to do it, but I need you to pay very, very close attention to that where clause. It is absolutely positively critical. If you forget it, if you just say delete from employee, you are telling the database to shred every single file in that drawer. So please, always be specific when you delete. And there's the result. We won our safe command, and poof, the record for employee number 7 is cleanly and permanently gone. Our data is now up to date. It's that simple, but also that powerful. All right, let's zoom out for a second and recap. You now have the 4 fundamental commands that make up the core toolkit for working with data pretty much anywhere. It all follows this really logical life cycle, right? First, you create the structure. Then you insert your information into it. You use select to ask questions and get what you need. And finally, you delete data that's old or no longer relevant. These 4 commands, they are the foundation for everything else in SQL. And remember, this isn't some abstract coding exercise. This exact logic is happening millions of times a second, all around you right now. When you filter for sci-fi movies on your streaming app, that's a select query with a where clause. When an online store shows you only the shoes available in your size, that's another one. You now understand the basic grammar of how our digital world gets organized. So there you have it. You've learned the language. You know how to build the cabinet, file the information, and ask for it back in any way you want. The only question left is, if you could get your hands on any set of data in the world,